All right, so the next lesson in this module, we're going to be talking about the secure control plane deployment, right? And we talked about, the difference between the data plane and the control plane as part of this process. But in this section here, we're going to kind of do a deep dive into zero-touch provisioning. How do we configure the Vedge devices from the command line interface? How do we register those Vedge devices in vManage? And then how do we verify those control connections and then also verify the certificates? So this is kind of more of a practical approach to implementing all these things that we've been talking about in our previous lessons. All right, so this is going to be an interesting section. I think you'll find this will be pretty interesting. So what is zero-touch provisioning, right? Now, the book kind of describes the whole zero-touch provisioning process step by step, and I think that's important to understand. But before we do that, I want to kind of talk about, in general, what does zero-touch actually mean in this particular case. There are basically three major capabilities of any kind of zero-touch provisioning process, right? One is plug and play, the other is self-authentication, and the last is what we call air-gapped ability, right? So let's start by the plug and play, right? SD-WAN is really about improving the administration of the overall WAN itself, but also about improving customer experience, right? We need to eliminate the need to send an expert to deploy our SD-WAN endpoints, our distributed endpoints. We still need an expert to do the core pieces, right? To talk about the vManage and vSmart controller and so on, and orchestrator or vBond. But the only action that a customer needs to take with a true ZTP process is to connect a cable on a WAN port and then have that device basically connect and configure itself through some sort of cloud-based service that provides not only the discovery of the device, but also an activation mechanism for that particular device. All right. Now, any other step, connecting to every device and then pushing a file with email or mobile app or whatever, is really extra effort, right? Extraneous information that's not part of the ZTP process. So that's the first component of the three main capabilities. The second is self-authentication. Security is non-negotiable. We've talked about that many, many times as part of this process. And in the case of ZTP, the device needs to be able to self-authenticate and receive its provisioning information from some sort of centralized managed resource. So it has to be able to talk to vBond Orchestrator automatically, and then it has to register to vSmart controllers, register to vManage, and then also register to other Vedge devices. But all of that has to happen automatically. So again, we're trying to minimize the malicious actions in the network. Maybe infected devices being added to the overlay network or unauthorized devices being added to the overlay network. So that's the second piece, right? The third piece is air-gapped ability, right? And what we mean by that is the SD-WAN itself is really kind of known for using these direct internet connections as a way of improving overall WAN performance, but reducing costs, right? But what if we have an organization with air-gapped networks that want to enjoy, or at least not enjoy, I guess that's not a great term to use, but at least get the benefit of centralized WAN management, right? We want to be able to have the segmentation. We want to be able to have that zero-touch provisioning. And some SD-WAN solutions that exist, not Cisco of course, but other SD-WAN solutions that exist, they can't accommodate for air-gapped communication. So you have to have some sort of staging environment with some sort of internet connectivity, and that's, again, contrary to the whole ZTP process. All right? So the Cisco SD-WAN solution does provide this completely isolated or air-gapped network provisioning process because we actually implement a Cisco Cloud ZTP server that has a plug-and-play portal that you connect to be able to provision these endpoints. All right. So there are some prerequisites. If you're going to do any kind of ZTP onboarding, you need to make sure that you meet specific prerequisites to be able to do the onboarding piece, right? You have to make sure that the WAN edge device has reachability to the vBond orchestrator, the vManage platform, as well as the vSmart controllers. The WAN edge devices have to be in a device whitelist, and that has to be uploaded to all of the controllers, vBond orchestrator, vSmart, and vManage. We can actually do this. We talked about this. We were just talking about this on the break, right? We can actually do this by adding and associating those WAN edge devices with the vBond controller profile. There's actually a plug-and-play portal in the vBond controller that we can add this to. And then that whitelist can either be created manually or it can actually be downloaded from a PNP portal and then uploaded to the vManage NMS or synchronized to the vManage with a Cisco ThinkSmart account, right? And I don't know if we'll actually see that later on, but there's a way to kind of automate the process even when we're talking about getting the information from the vOrchestrator or vBond orchestrator to vManage. All right, and then vManage can then distribute that information to other additional controllers in the network. Obviously, you have to have a valid staging certificate. The WAN edge device has to be running the appropriate SD-WAN software, the right versions of software, and there always has to be, the vEdge devices have to be able to resolve ztp.viptela.com. That's how we get to that ZTP server in the cloud, right? You also have to make sure that the WAN edge device is factory defaulted before we do the onboarding and bootstrapping option, because there's some settings that need to be set initially that have to be defaulted to their default values. Make sure that the vEdge devices are entered into your PNP connection portal, and they're associated to the vBond controller. That's going to be done at software.cisco.com, using your standard CCO account and associating the devices. If you're using an on-premise, not a cloud-based ZTP server, that ZTP server needs to have all of the entries of the authorized vEdge devices with the vBond controller information, the organization name, like we mentioned before. We can also install the root CA certificates, which is going to make the zero-touch provisioning process much more efficient, right? It's actually kind of required in this case. All right. The WAN edge configuration should already be built, right? We need to make sure our policy configurations, our templates, and everything else are already built in vManage so that when the device connects, it can provision itself. And the software versions of the vEdge devices don't necessarily have to be upgraded prior to attachment, because that eliminates the whole kind of zero-touch concept, but they can be upgraded through the registration process. All right. So we have two ways that we can provision a vEdge device. What we're talking about in this case is the first option, which is a zero-touch provisioning. That's basically a day zero automated ZTP process that gives us a way to discover, install, and provision those vEdge devices into the overlay network. The other option that we have is to manually configure the vEdge devices. We use a console port, or we use some sort of KVM ESXi console connection if it's a virtual edge device, as opposed to a physical iOS-based edge device, and then we can configure the devices manually. Obviously, that's not ZTP in this particular case. All right. So when we have the automated deployment for our Vedge device and we're using ZTP, the platform itself is initially onboarded with ZTP to the overlay network. Once it gets onboarded, then we do a code upgrade. That's optional. You don't have to do a code upgrade, but it's generally recommended. You want to have a consistent code on all of your platforms. And then the device is registered to the overlay network, right? So, and all these prerequisites, by the way, are all this documentation is available on Cisco.com and talks about, you know, the step-by-step process to provision these devices. I'm just kind of summarizing what I've seen in the past when I've done deployments, right? The factory default device has an interface that's actually pre-configured with IP DHCP client so that it can dynamically procure an IP address and then register itself with a controller. All right, so the first thing that happens, and this is kind of what they're talking about in these steps here, the 1, 2, 3, 4, all the way up to the 11. The first thing that happens, actually my first thing is we always connect the Vedge device to some sort of WAN transport. Obviously that's going to be really technically the first thing that has to happen, even though they don't mention that here. The first thing they say is we're going to go ahead and power on the device, right? Once the device boots up, it will dynamically obtain an IP address, a gateway, a DNS information through the DHCP process from an upstream WAN transport device. That's why we see DHCP listed at the far right for step number 2. Then that Vedge device makes a DNS request to ztp.viptela.com, the ZTP server. Then the Vedge device reaches the ZTP server, which is the, I guess in this case, circle number 4, which then gets, the device presents its chassis ID, serial number, certificate, etc. We talked about that in the previous lesson to authenticate itself to the ZTP server. Post-authentication, once the device is authenticated, the ZTP server provides information about who the vBond orchestrator is, what the organization name is, and it provides the root certificates to the platform, right? Now, if you are using a deployment where we have an enterprise CA, we're going to download those enterprise root certificates along with the vBond IP address, DNS information, and organization name. That information is actually used by the Vedge WAN device to initiate control connections to the vBond controller itself. So that's why it's important to download that information. All right. So they don't mention that here in this particular slide, but that's something to just consider when you're using an enterprise CA as opposed to, say, like a semantic CA. All right. Now the Vedge device, once it gets these details from the ZTP server, it tears down that control connection and then it instantiates or it initiates a transient connection to the vBond orchestrator. That's that temporary DTLS tunnel or whatnot. So once we authenticate to the vBond orchestrator, then the Vedge device is provided with the vManage information and vSmart information to register and establish the secure connection. Then we attempt to establish a secure connection to vManage. So we're now kind of on step number 6, if you will. But it's important that the device itself has no configuration, right? So to build the connection at this point, it's going to use a quad 0 address as its system IP just to kind of initiate that initial control connection with vManage. So that's kind of where the step 6 is in this particular case. Post-authentication, vManage sends information back to Vedge with the device's system IP address and then it forces the device to re-authenticate using a shared system that shared system IP information. And that's where we see we're going from step 6 to step 7. We reinitiate control connections to vBond, actually to vBond and vManage and vSmart controllers using that particular configuration so that we can join the overlay network. All right. So they don't actually have that depicted in the diagram here as well, but it's not just vBond, but it's also vManage. I guess in this case, they're actually referencing that as step 7, step 8, step 9, and step 10. And then that's when we get to join the overlay network. All right. Now, like I said, one of the options that you have in this process as well is you have the option to force an upgrade of the Vedge device. If you go under vManage administration and then go under the settings, there's a checkbox called Enforce Software Version, and in parentheses it just has ZTP, so it's talking about the zero touch provisioning piece. If that is checked in that configuration option, then the device is going to download its software and it's going to get upgraded. All right, now once I've updated the software, I go through the whole re-authentication process with the controller. We join the overlay network. All right. After that's done, the next step would then be to just verify whether or not the device has successfully been onboarded. That's where you go into the vManage device pane dashboard. You go to your quick view and you can see the number of WAN edge devices that are onboarded to your overlay network. If you want to see the entire bring up process, we can go to configuration and then go to devices. And then we choose the device from the WAN edge list, click that elliptical button, and then select the device bring up from those options. And then we can see that all the details of the device bring up process. All right. We have to make sure that the device is authorized by vBond. We also have to make sure that the software image update was successful, that the router configuration was added, because that would happen after the software update, and make sure that the control and data plane connectivities are established. And that's where we can see that detailed information. All right? So that's that process. Now, the Vedge routers themselves, we're going to configure system parameters that include things like the host name, the system IP, the site ID, organization name, the vBond IP address, and DNS name. Now, out-of-band configuration is done here, and I mentioned that I was going to talk about a couple of different VPNs that are established for this process. There's two different default VPNs that exist in the overall communication process. We can see them kind of referenced here. Well, at least one of them is referenced here, VPN 0, right? VPN 0 is used to establish reachability to the controllers. That VPN 0 network interface has an IP address. We have a tunnel interface. We have encapsulation. We apply a color. And we also apply our routing to that interface, whether it's dynamic or default routing. But we also have an out-of-band management interface, which is called VPN 512. VPN 512 has an IP address and a default route. And we'll get more into the VPNs and how they're used in this architecture a little bit later on. But those VPNs are used for the provisioning and management of the device itself. So once we've configured the tunnel interfaces, the actual tunnel interface and the WAN edge devices will use DTLS and TLS, or TLS I should say. We don't use them together, but one or the other, to establish that control plane session with the SD-WAN controllers. And then IPsec is used to establish the secure data plane connectivity with other WAN edge devices on the network. All right. So that is, in essence, that process. Okay. Now, as we let me move forward here. you can see some of the configurations on the Vedge router here. What we're seeing in this case is we're opening up a CLI session with the Vedge device using SSH, and we're going into configuration mode by typing config. We don't type config-t, we just simply type config, and the prompt changes to config mode. We set the system host name by using the system host name command. You don't have to set the host name. It's not actually really used. It is kind of recommended just so that you know what kind of device you're accessing, and you will see it in a lot of the different vManage NMS screens, but it's not actually really technically used for any registration process or anything like that. We set the system IP address. It can be IPv4 or IPv6, depends on the software version, but I think it's 16.3 and above will allow IPv6. We use the system-IP command, then put in the IP address. We configure the site ID, the site-ID, site ID command under system configuration. And then we specify the IP address of the vBond orchestrator. In this case, they specified an address of 10.2.6.2, or we can use a DNS name as long as we have DNS configured. But typically we try to use an IP address only because we don't want to have just another layer of we want to try to get rid of that DNS reliance, right? Because if DNS fails, then the registration process is going to fail. All right. Now remember, the VPN 0 interface, that's used as our tunnel interface. That is the WAN transport VPN that carries all the control traffic to the other devices in the overlay network. It's not used for management, but we give it an IP address, specify the encapsulation, specify the color, what kind of services we're going to allow, turn on the interface, and then we specify our IP route, and that's a default route in this particular place, in this particular configuration, and then we just apply the configuration. Okay. Now we will get into later on the different VPN interfaces. There's only really two standard ones, VPN 0 and VPN 15. But you have to have at least one interface in VPN 0 for the overlay network to even be established, right? To be able to communicate from the Vedge device to vManage and to participate in the overlay network. You can have more than one interface participating in VPN 0. And remember, these interfaces that we're talking about, these are physical interfaces to the transport, right? Whether it's an MPLS connection or whether it's a broadband Ethernet internet connection or LTE connection, doesn't matter. But we're actually associating this particular interface to the VPN by applying a color, by specifying that it is a tunnel interface. And we're associating that interface to the VPN 0 by referencing the interface under the VPN 0 interface itself. If that makes sense, right? We're kind of associating, in this case, interface gig Ethernet 01 to VPN 0. But there could be multiple, right? The colors themselves could just simply represent the transport. That's what the colors are used for, to identify the type of WAN transport. So MPLS or Metro Ethernet or whatever it might be, and we would define those as part of our template configuration as well. All right. All right. Now, we talked about this in the vManage platform. We have to upload the configuration file, which is that text file that includes all of the devices that want to register with vManage. We actually upload that file through the NMS, and that's going to include the serial numbers and the chassis numbers to the Vedge devices. That's then going to be propagated to the vSmart controllers, and then the vSmart controllers are the ones that are going to actually authenticate and validate those Vedge devices by matching those serial numbers and chassis numbers to the process, right? The serial number, like I said, that's a 40-byte number that includes that's included in the device's certificate, the actual PKI certificate that we exchange, and then the chassis number is part of that TPM configuration, which is also globally unique on that particular platform. So by combining the serial number and the chassis number, we know that there's a one-to-one mapping between them, but that's going to identify that device uniquely in the architecture. Okay, so the controllers, the vSmart controllers and the vBond orchestrators, they're going to learn about the serial and chassis numbers during the initial configuration of the devices themselves. So the vSmart authorized serial numbers is going to get propagated, and the Vedge authorized serial number file needs to be installed, right? So vManage learns about the serial numbers from all of the vSmart controllers that are allowed to be in the network while it's creating the certificate signing request and installing those signed certificates. We download those serial numbers to the vBond orchestrator, and then the orchestrator pushes them to the vSmart controller during the authentication and registration process, right? And that we still have to install that manually on the vManage, but it's going to get pushed to the vSmart controllers from the orchestrator itself. That Vedge authorized serial number file, that's going to contain all those serial number and chassis numbers. That needs to be uploaded to the orchestrator and the vSmart controllers. So that's what I was talking, you were asking about that earlier. And that's what I was talking about, how you have to upload that file to basically all the devices, all the controller devices anyway, not the edge devices, but the controller devices. All right. So it's really two different pieces to the registration process. Okay. So when I'm registering Vedge devices with the NMS, there's 5 different steps that we have to go through. All right. I log into the vManage platform, I go to configuration, and I go to the devices screen. From that devices screen, I can click on the Vedge list, and then I can click the upload Vedge list option, and then I would select the file that I want to upload. That's going to be that serial number file, and we only upload that serial number file to vManage. All right. The file gets uploaded to vManage, and then we send it to the controller devices in the network. We have to check the box that says validate the uploaded Vedge list and send to the controller's checkbox. I don't know if you can see that on the screen here. Yeah, it's right there on the top left, right? You check that box. If we don't send the serial number file to the controllers when we upload the file to vManage, then we have to send it manually. So typically we would do this anyway, send it automatically by checking that box there. If I need to do it manually, I have to go into configuration, I have to go to the certificate screen, and then from that certificates, I go to the Vedge list, and then I can say send to the controller from there. And it's a push operation where I'm sending that information to the controllers in the network. All right. When you actually upload the serial number file, it will place the Vedge routers into one of three different states. Either invalid, so basically it's a Vedge device that hasn't been listed in the file and it's not registered. Staging, so these are validated and authorized to join the overlay network. They can actually establish control plane connections, but not data plane connections. So they can participate in the SEN from a registration standpoint and a management standpoint, but they can't establish a data plane connection, so they're not going to be able to establish any kind of communication to other Vedge devices in the network. So this would be like if you've got some Vedge routers that you're about to ship out or you're about to deploy. but they're not actually physically plugged into the location where they're going to be installed. You would set them up as a staged Vedge device. You'd move them into the valid column or move them into the valid position once they've been deployed at their physical location. All right. And then finally valid, that's when you power up the Vedge router. It's been obviously validated and authorized to be part of the SEN, but it's able to establish both the control plane connections as well as the data plane connections, and they communicate in the overlay network just like a regular endpoint, right? Just like any other already previously configured endpoint. All right. So this is where we would want to have the devices at their final location. They're participating in the network, just as, you know, kind of a regular device. Okay. If I want to activate a Vedge cloud router, that's slightly different. It's not completely different, but it's slightly different. We still have a serial number file. Obviously, we don't have the specific IDs that we would have. The chassis number is kind of virtual in this particular case, but there's a token that gets generated by the NMS for each of those cloud routers that gets listed in the file. And that token is a kind of a one-time password, if you will, that allows the cloud router to register to the NMS. And that's sent to the vBond orchestrator and the vSmart controller as well to identify that endpoint. All right, and you can see the commands here on the Vedge device: request Vedge cloud activate chassis number, token number, and then on the device we would also use the show control local properties. We'll talk about that command here in a little bit. All right. All right. So when we're verifying control connections, there's several different commands that we can use, right? We can monitor the WAN edge device through vManage. There's an SSH server that's built in. Remember that SSH server dashboard that we talked about? It was one of the last dashboards that we looked at in that section. And then we can use those CLI commands to manage, to run CLI commands on through the GUI on the Vedge devices, right? So we don't have to actually use a separate terminal session for that. We can do that, but we don't need to because we can do that through vManage. So you go to under Tools, SSH Terminals. You select the WAN edge from the devices group because that's what we're looking to communicate with, the Vedge devices. We verify that the WAN edge devices have established a secure control connection with the controllers. We can actually use the command show controller connections. That's going to show us the Vedge devices, or we can do a show SD-WAN controller connections for the iOS XE SD-WAN devices. So it depends on which type of device you're trying to authenticate, right? But we can see there's some other options here: show control connections history, local property, statistics, summary, etc. I'm going to talk about several of these throughout this process, and we're going to see some sample outputs, right, from this in the screen here. Right, so here's an example of show control local properties. All right, so to verify device properties that were used to authenticate the WAN edge device, we use the command show control local properties, and you can see the output here. Things like organization name, certificate status, what's the validity time of the certificate, what's the site ID, what is the serial number, and what is the IP address, port number, etc. Right? Or on iOS XE devices, they don't have that listed here, but if it was an iOS XE device, I would just use the show SD-WAN control local properties local dash properties. That's pretty typical with a lot of these commands. If it's a traditional Vedge device, you're going to use show control. If it's an iOS XE device, you're going to use show SD-WAN control. But they pretty much provide the same outputs, the same properties. With this particular output, there's a couple things that you want to make sure that you verify, right? Make sure that system parameters are configured to include things like organization name, site ID. Make sure that you verify the certificate status, and also make sure that you verify that the root CA chain status show installed. All right. Make sure, of course, that the certificate is valid. Make sure that the DNS name, this is really important, is pointing to vBond, right? The vBond IP address is the DNS name. The system IP has to be configured. The chassis number, the unique ID, the serial number, the token, those also have to be available on the device as well. These parameters all have to be available on any WAN edge device to allow it to mutually authenticate with the SD-WAN controllers before they actually establish a connection. All right. Here we're seeing some additional output show control connections. Gives us the different peering information, how it's being peered, if it's TLS or DTLS. So we have a couple of connections to some vSmart controllers. We have a DTLS connection to a vManage device, a couple of DTLS sessions to vBond orchestrators, and so on. What are the port numbers that we're using? What is the private IP address? What is the public IP address? In this case, they're the same addresses. We'll get into the addressing piece a little bit later on. What is the color, right? What is the state, uptime, etc. All right. Let's see. I don't think there's anything else here. Obviously, here we're seeing show control connections. This, again, provides us basically the same information, right? This is the information on the vBranch, and then this is the information on the vSmart controller. So obviously, it's going to have more information than the branch would have. All right. To verify reachability of the vBond controller from the WAN edge devices, let's say, for example, a WAN edge device fails to set up a connection with the controller. We can actually use the command. I don't know if they have it here. Let me see if it's on the next slide. Yeah, it's not. I don't see it here. They don't have it. But I want to talk about some of the other troubleshooting commands that you can use, because I've used these many times in the past, right? That's typically when you're kind of involved in the CLI, is when something's not working. So you're trying to verify why something's failing. But like I said, if a WAN edge device fails to establish a connection with the controller, one command that's really useful is the show control connections-history, or show SD-WAN control connections-history. And we're looking for, in that output, I wish they would have had one in here, but in that output, local error and remote error columns. A local error column and a remote error column will identify what the potential problem is and why that device can't connect, right? And there's basically 4 different outputs that you're going to see there. There's a CRTV ERFL. That's an acronym for control. I don't know what it stands for, but I always see it just as CRTVERFL. That basically tells you that authentication is failing because the root CA certificates don't match. There's a mismatch between the WAN device and the controller. And then we can go and start investigating the certificate issues by using the show certificate root-CA-cert or show SD-WAN certificate for iOS XE devices, and so on. And then we start troubleshooting the certificate problems, right? So that CRTV is obviously certificate. Now I know. Certificate verification failed. That's what it stands for. CRT VERFL, certificate verification failed. Another one that you'll see is CTORG NMMIS. CTORG NMMIS. Basically what this one means is that the WAN edge device authentication is failing because of the properties, right? Maybe it's a mismatch organization name. Make sure you compare the organization name. Obviously the ORG stands for organization. CT is controller. ORG is the organization. N is name. MM is mismatch, and so on. So they kind of give you, the names of these errors kind of give you some sort of indication as to what it represents. But that's, we would actually use the command show control local properties to verify that. We already saw that command, and so on. Make sure that matches. The other one we might see is no ZTE, no ZTP-EN, right? Basically, you kind of can guess what that means, right? Basically, the onboarding has failed because it's not either part of an authorized whitelist, so it can't communicate to the ZTP server. So we might use, for example, the show ZTP entry command on the on-prem ZTP server if we're trying to verify whether or not a device has been added to the ZTP server for provisioning. No VM CFG means that there's no template in vManage, right? So there's no configuration template. So the device can communicate, but it hasn't been attached to a particular configuration template. So the onboarding process will fail because we can't get a configuration. Now there's some others we might see: VBTMO, VMTMO, VPTMO, VSTMO. These are timeouts to the different controllers. Basically, we've lost reachability to specific controllers and so on. All right. Keep in mind that if the root CA chain certificate is missing, the device will not be able to register, which means it's not going to be able to establish a communication channel with the controllers in the network. So the certificates are really, really important. I think 9 times out of 10, that's where you're going to see the problem is with the certificates themselves. All right. All right. So here we're just looking at, again, another dashboard screen that kind of gives us information about, you know, where we can see, you know, whether a control plane is established on a device, you know, whether that control plane is active and so on. We had talked about this previously when we were going through each of the individual dashboards. All right. All right. Also here, if we want to look at a single device, we talked about this in the dashboard screen as well. We see a control connection for a single device. We can see what it's kind of connected to, how it's established its connection, and so on. All right. Now, for certificates, if I want to verify certificates, there's a couple of different commands that I can use to verify certificates in the platform. I can use a couple of different commands here. Let me see if I can. So we already talked about the concept that if a device is missing, if we're trying to onboard a device, right, and it's missing the root CA certificate, authentication is going to fail, right? We can't establish a control connection to the controller, and obviously the rest of the process is going to fail. The root certificate itself is downloaded actually to a specific directory on the Vedge device, and that's the home directory. And I think inside the home directory, there's an admin directory as well this gets installed. All right. So we can actually use a command to install that certificate. That command is pretty straightforward. It's request root-cert-chain install. And then we specify the directory and we specify the PEM file name that we're trying to get from the directory, right? We verify that this root CA certificate is actually installed by doing a show certificate root-ca-cert, right? Now we're seeing a show certificate installed, which shows us all of the certificates, but if I want to see that root certificate, I would do the show certificate root-ca-cert. Once we've established a secure connection with vManage, the template gets attached to the WAN edge device and overwrites whatever configuration exists on that particular device. It'd be kind of like the basic configuration. But we also have to gather information about the device that's needed to input into the plug-and-play portal for this zero-touch provisioning, right? So we need information like show license UDI, show crypto PKI certificates, get the certificate serial number from the certificate section and so on. We talked about that when we were talking about the zero-touch provisioning process. All right. The show certificate serial command will give us that information as well. Here we're seeing that information as well. We can see, I don't know, do we have that on here? It's kind of truncated. We see the serial number. But we don't really, yeah, we see the serial number here. It's right at the top, 4118 in this particular case, okay? So with vManage, we can also do the same verification. We go under configuration, go to certificates, click on controllers, and we can see the certificates on each controller. We can hit the elliptical button and manage that information directly. There's a couple of options that we have with the elliptical button that we can use to manage that certificate. But again, it's kind of, point and click. I mean, it makes sense what you're gonna see when you're accessing that information. The certificate information this is just a graphical way of seeing that information. We can, if we hit that elliptical button on the right, we can do things like view the certificate itself, like get the details of the certificate. The little pop-up will pop up and we can see that information. All right. All right. Let's see. Yeah, nothing else on this slide. I mean, it's pretty self-explanatory what you're seeing on this slide here. All right. What happened to my mouse? Come on, mouse. It is. All right, this is what I actually was referring to, right? This is the elliptical button. We can view this certificate signing request if we have a pending request. We can view the certificate. We can generate a certificate signing request. We can reset the RSA certificate and kind of go through the process all over again. We can invalidate a certificate. In this case, we're just viewing the certificate and we can see the serial number here, 4118. We can get this information from well, this is vBond Orchestrator. Yeah, we can get that information from command line if we need to. We don't have to use the GUI. All right, so that brings us to the end of this lesson. We talked about automatic provisioning, zero-touch provisioning, which is basically software as a service. That allows our vEdge routers to join the overlay network automatically. We talked about how that ZTP process begins when you power on the device, and we talked about the different steps that we go through. We talked about the default configuration, the information that has to be included, system IP, site ID, organization name, host name, etc. The serial number file that lists the serial and the chassis numbers for all the vEdge routers that are allowed in the network. Those have to be registered to the vManage NMS, and then that vManage NMS sends the serial and chassis numbers to the vSmart controller, which then allows us to authenticate the vEdge devices to the vSmart controller so they can join the fabric, right, the SEN. We also talked about the control connections between the controllers and the vEdge devices. and they can be verified from the CLI. And then we finished up this section by talking about certificate installation and certificate management, some of the command line commands that we have, as well as the vManage GUI or dashboard panes that we have to manage the certificates. All right, so we'll wrap up this lesson. We'll see you guys in the next lesson.